On to problem number one of the round one of the 2006 MIT Integration B regular season challenge. So the first problem was the indefinite integral of the square root of x over 1 minus x cubed. And so this is a very interesting problem. Sadly, none of the contestants was able to solve this problem in the allotted time. We'll show you a video of their attempt. We're going to kind of go fast through it, and then we'll introduce our version of the solution. The integral of the square root of x over 1 minus x cubed. We could also express it as the integral of x to the power half over the square root of 1 minus x cubed. The important thing to note is the numerator there, and this is because we want to substitute for the complex expression, such as x to the power half or whatever, x to the power 3. What we see there is that x to the power half is derivative of x to the power 3 over 2. So if we say let u be equal to x to the power 3 over 2, then we find that du dx is equals to 3 over 2 x to the power a half. And so what happens is 3 over 2 du can be used to substitute for x to the power half dx. And this is very important because now we can deal away with whatever is in the numerator. And also surprisingly, u here becomes x to the power 3 is the same as u squared. In other words, x to the power a half dx over the square root of 1 to the x3 is the same as 2 over 3. This part here becomes du, as we saw, over the square root of 1 over u squared, because x to the power 3 is the same as x to the power 3 over 2 squared. And this is a very easy integral to solve, but one would want to use the substitution of let u be equal to sine theta, such that du d theta is equals to cos theta, and therefore du is equals to cos theta d theta. Now, using this substitution, we can now say that 2 over 3, the integral of du over the square root of 1 minus u squared, is the same as the integral of 2 over 3. Du is cos theta d theta over the square root of 1 minus sine square theta. And 1 minus sine square theta is the same as cosine square theta. Square root becomes cosine theta. So we have cosine theta d theta over cosine theta, and that cancels. So we have the integral of 1. And so this becomes 2 over 3 theta plus c. And since u is equals to sine theta, we see that theta becomes arc sine of u, and so our integral becomes 2 over 3 arc sine of u plus c, but u is the same as x to the power 3 over 2. So what we get here is that our big integral x over 1 minus x to the power 3 dx is the same as 2 over 3 arc sine of x to the power 3 over 2 plus the integration constant. And that happens to be our answer. So we could easily have solved that in under 4 minutes, but here. That's the solution. On to problem 2, the indefinite integral of x to the power negative a half over 1 plus x to the power 1/3. So again, sadly, none of the contestants was able to solve this problem. We'll kind of slide through the attempt by these contestants on trying to solve this problem, and then we'll introduce our version of the solution to this problem. Our problem as we introduced it was x to the power negative a half over 1 plus x to the power a third. Usually what you do is you anticipate that the numerator is something that is derived from a derivative of some other function. But with this, I would like to express this problem such that I have a common variable that I could substitute off, and that what I see here is x to the power 6th is something that would help me remove the fractions in the powers. So we have x to the power 6 squared here, and so if we say let u be equal to x to the power 6, that means du dx is equals to 1 over 6 x to the power negative 5 over 6, which means that du is equals to a 6 u to the power negative 5 dx. So that implies that a 6 du over u negative 5 is equals to dx, which means 6u to the power 5 du is equals to dx. So we're going to use this substitution, and so if we have x to the 6 the power negative 3 over 1 plus x to the 6 to the power 3 at the equals to u to the power negative 3 over 1 plus u squared, and then we have 6u to the power 5 du. And this becomes u to the negative 3 times u to the power 5, and if we pull 6 out, it becomes u squared over 1 plus u squared du. So we have 6 u squared over 1 plus u squared du, which is the same as 6 integral of 1 minus 1 over 1 plus u squared. So just doing the long division. And so this is a very interesting integral, arctangent of u. So we have 6u minus 6 arctangent of u plus the integration constant. But we know since u equals to x to the 6, we can say that our integral that we started with, x to the power negative a half over 1 plus x to the power a third dx is the same as 6 x to the power 6 minus 6 arctangent of x to the power 6 plus the integration constant. And that, ladies and gentlemen, is our answer. Problem 3 of the MIT Integration B regular season 2006 is the indefinite integral of x times the hyperbolic cosine of x over the square of the hyperbolic sine of x. Now, none of the contestants was sadly again able to solve this problem in the allotted time. We'll show you that attempt and then rush into our version of the solution for the problem. Indefinite integral of x times hyperbolic cosine of x over the hyperbolic sine of x squared, right? And this we could express as x times the hyperbolic cotangent of x, hyperbolic cosecant of x. An important thing to note here is that the derivative of the hyperbolic cosecant of x is equal to the negative hyperbolic cotangent of x, hyperbolic cosecant of x. Right? So this is just something to have in mind, so that our integral is simply x times the derivative of the hyperbolic cosecant of x. And so using integration by parts, since our integral is now that, we know integration by parts if you have the product of two functions, one v and the derivative of function capital U, that's the same as the product uv minus u, the derivative of v. So that's just a known. So from there we can see that we have negative of x hyperbolic cosecant of x plus derivative of x, x being v, we have hyperbolic cosecant of x integrated. So this is where I think many people would get tripped, since we have this as our I would like to express everything in terms of the exponential function. So this is 2 over e to the power x minus e to the power negative x. And this becomes negative x cosecant x plus pull 2 out, and then this becomes 1 over e to the x minus 1 over x. So the problem now becomes x plus 2 e to the x over e to the power 2x minus 1. So this is plus 2 e to the x ex over ex plus 1. Difference of two squares. And so we can use partial fractions there. For me, it's very easy to see that this that's the same as a half And so 2 over 2 of e to the x over ex minus 1 minus ex over ax plus 1, right? So we get x cosec plus e minus ex over ax plus 1. And from here we can easily see that the numerator here happens to be the derivative of the denominator for both parts of the fractions, and it's straightforward to know that we have natural logarithm of ex minus 1 minus log of ex plus 1. So this is ex cosec hyperbolic cosecant of x plus rules of logarithm. We have ex minus 1 over ex plus 1 plus the integration constant, which we don't want to forget. So we have x hyperbolic cosecant of x plus log of ex minus 1 ex plus 1, and it's easy to see that if we divide both the numerator and the denominator by e to the power, I'm talking about here, by e to the power x over 2, we get ex over 2 minus e negative x over 2 over ex over 2 plus e negative x over 2, right? Which is the same as the natural logarithm of the tangent of x over 2 plus the integration constant. So what our answer now for the problem we have at hand is equals to natural logarithm of the tangent, hyperbolic tangent, minus x cosecant plus the integration constant. So I apologize, I think I'd written just tangent of x over 2, but it's hyperbolic tangent of x over 2. And that is the solution to our problem. So, yeah. On to problem number 4 of the MIT integration B, regular season integration B, the indefinite integral of e to the power cosine of x. So again, no one was able to solve this problem in the allotted time. We'll show you that scene and then rush into our version of the solution to the problem. This is our problem, right? Cosine of x. The quickest thing would be for us to say let u be equal to cosine of x, and that means cosine of u equals to x. That means that sine of u negative du dx is equals to 1, and that means sine u du equals to dx. So that is the initial substitution, so that e cosine of x would be equal to e u, and in place of dx would have negative sine u du. Okay, so we have the integral of negative eu sine u du, which can also be expressed as a negative sine u times the derivative with respect to u of e to the u. So using integration by parts, where we have a function v and du being equal to v integrated is equals to uv minus u dv. If we consider negative sine u as v, then it means that our uv would be negative eu sine u plus the derivative of sine u, negative, it becomes negative cosine u, so we have eu cosine of u. Okay, so as we continue, we have negative eu sine of u plus eu cosine of u, and that means we can still say we have cosine u and then the derivative of e to the u. Using the same idea of integration by parts, we find that we have plus eu cosine of u here minus so minus because the derivative of cosine u is going to be equal to sine, so minus this becomes a positive, and so we have e to the u sine u. Okay, and since our initial integral was e to the power u sine u du on this side, and if we take only this part without as I, we see this is I, and so we have negative I here as what we need to know. So if we pull out this I this side, we get 2I being equal to negative eu sine u plus eu cosine of u. So negative I becomes a half of e to the sorry, it's just e to the u, there's no negative there, so e to the u, there's a negative here, sine u plus e to the u cosine of u plus the integration constant, but u is equals to a cosine of x. That means that cosine of u is equals to x, and that means that sine u, which is sine squared u, is equals to square root of 1 minus x squared. This is sine of u, and that means that our interest, which is negative I, e to the power cosine of x dx is equals to a half. We'll pull the e to the power u out, e to the power cosine of x times, let's begin with cosine u. Cosine of u is x minus sine u, which we found to be the square root of 1 minus x squared, plus the integration constant. And that, ladies and gentlemen, is our answer. Problem number 5 was the indefinite integral of 1 minus sine x over 1 plus sine x. Again, this is a fairly easy problem, but sadly, none of the contestants was able to solve this problem. We'll show you that scene, but also go into introducing our version of the solution. Problem number 5, this is actually very easy. So 1 minus sine x over 1 plus sine x. Okay, so how we would solve this is multiply both the numerator and the denominator by 1 sine x. Okay, and so you get 1 minus sine x, actually 1 plus sine squared x minus 2 sine x over 1 minus sine squared x. So let's just confirm, yeah, so that it is. And 1 minus sine squared x is the same as cosine squared x, so we're just going to replace that with that. We have cosine squared x. So our problem now is 1 over cosine squared x plus sine squared x over cosine squared x minus 2 sine x over cosine squared x, which is the same as the integral of sec squared x plus tangent of squared x minus 2 tan x sec x. We'd like to convert this also to sec x, since 1 plus tan squared x is equal to sec squared x. So this is sec squared x minus 1 tan x sec x. So we now get the integral of 2 sec squared x minus 2 tan x sec x minus 1. And so sec x is the derivative of tangent x, tan x sec x is the derivative of sec x. So we get 2 tangent of x minus 2 sec of x minus x plus the integration constant. So succinctly expressed, we can just say 1 minus sine x over 1 plus sine x integrated, the same as 2 tangent of x minus 2 sec of x minus x plus the integration constant. And that is our answer. So that was actually a very simple problem, but I think where one of the contestants really struggled was in how to integrate tan squared x and couldn't figure out how to transform tan squared x into a sec squared expression. So sometimes being able to nimbly, or in a nimble way, be able to shift between these different expression is very important, and would help you a long way. So trigonometry and calculus are so much inextricably linked, and it's very important to have a firm grounding in both topics. Problem 6 is the definite integral from x equals to 0 to x equals to pi over 4 of sine x times cosine 2x. An interesting problem, also quite easy. However, none of the contestants was able to solve it. We'll give you a snippet of that video and then introduce you to our version of the solution to the problem. Problem here we have at hand is the definite integral from 0 to pi over 4 of sine x cosine 2x. And this is actually an interesting problem. Many people may want to expand cosine 2x, but I wouldn't. I would use the sine a plus b equals to sine a cosine b plus sine b cosine a. Similarly, sine a minus b is equals to sine a cosine b minus sine b cosine a. Now I would like to take the bigger of the arguments, 2x twice, to be a, and then the smaller x. So in other words, I would use this to sine b to be sine x, cosine a to be cosine 2x. And that means that sine a plus b minus sine a minus b would be equal to twice sine b cosine a, right? Therefore, you divide both sides by 2, and it's very easy to see that sine x rather sine x cosine 2x is equals to sine of 2x plus x minus sine of 2x minus x divided by 2. So this is a half of sine 3x minus sine x. So integral 0 to pi over 4 sine x cosine 2x is the same as a half the integral from 0 to pi over 4 of sine 3x minus sine x, which is equals to a half negative a third cosine 3x plus cosine x from 0 to pi over 4. And then what we'll do is we'll now just go ahead and substitute and see that negative that cosine 3 pi over 4 plus a third cosine of 0 plus cosine pi over 4 minus cosine 0. So which is a half. Cosine 3 pi over 4 is negative root 2 over 2. So we have negative and negative. We have a positive. So root 2 over 3 times 2 plus cosine 0 is 1. So a third. Root 2 over 2 minus 1. So let's keep a half outside. So we have, we can here root 2 plus 2 over 2 plus root 2 minus 2 over 2. Okay. So we have a half, a third root 2 plus 2 over 2 plus root 2 minus 2 over 2. We can pull a third out, and so we have root 2 plus 2 over 3 over 2, sorry. Plus 3 root 2 minus 6 over 2. So we have 1 over 6 and 2, 4 root 2 minus 4, 2, 2, 3, 1. So we do have root 2 minus 1 over 3 being our answer. So from 0 to pi over 4, sine x cosine of 2x is the same as root 2 minus 1 over 3. And that is our answer. Problem 7 of the regular season MIT integration B 2006. The definite integral from x equals to 0 to x equals to pi squared over 4 of sine of the square root of x. Interesting problem, also I think fairly easy. None of the contestants was able to solve this problem. We'll show you that part of the snippet and then rush into our solution to the problem. To problem 8 of the MIT integration B, regular season 2006. This is definite integral from x equals to 0 to x equals to pi over 2 of the cube of sine x. Sadly, none of the contestants was able to solve this problem. It's actually a very easy problem, but it just gets to show you how these problems, they may look simple, but they can get the best of us. So we'll show you that snippet and then rush into the solution that we propose. And yeah. Zero to pi over 2 of the cube of sine x, right? Or we may just want to express it this way. When the temptation is to want to do many things in substitution, but for me, I think what I would do is just do that, and then sine, cosine, so rather x, right? So let's maybe write that properly. So this is cosine minus, and so the problem now becomes from 0 to pi over 2 of sine x minus cosine squared x sine x. And as we can see here is that sine x is easy to integrate, but this expression is the same as the derivative of the negative over third cosine cube x, right? Such that when we integrate everything here, we have minus cosine x as an integral of sine x, and this obviously interacts, so we just have plus a third cosine cube x from 0 to pi over 2. Okay, so we say we have negative cosine x plus a third cosine cube x from 0 to pi over 2, and this is the same as negative cosine pi over 2 plus cosine of 0 for this part plus a third cosine cube pi over 2 minus a third cosine cube of 0, right? So this goes to 0, this is 1, so we have 1, and this goes to 0, and this goes to negative a third, so which is 2 over 3. In other words, our integral from 0 to pi over 2 of sine x cubed is equals to 2 over 3, and that is our answer. So on to problem number 9. The MIT integration be regular season. It's the indefinite integral of 2x over the square root of 1 minus x to the power 4. And this is actually an interesting problem. One of the contestants was just able to write the solution to it without any scribbling on the blackboard. So we won't be that intuitive in it, but we'll provide you just the quickest solution to the problem. But yeah, so this is what really was able to differentiate between the two contestants. And yeah, so let's see how we may be able to solve it. I'll show you the video of that competition, and then we'll just do a quick fast forward through it, and then we'll go into our version of the solution. To the last problem of this round, which is 2x over the square root of 1 minus x to the 4, right? And what I could do here is 2x is the same as the derivative of x squared, and then x to the 4 is x squared. And so if we could say let u be equal to x squared, we already know that du dx is equal to the derivative of x squared, and so du would be equal to x squared times dx. Okay, so let's just wrap that so that we're not confusing ourselves. And so this is u, right? And so our problem, that is equals to du over 1 minus u squared, and we can just say that u be equal to sine theta, which means that du d theta is equal to cosine theta, and so in other words du is equals to cosine theta d theta. So we're going to use this substitution to say that du over the square root of 1 squared is equals to the integral of cosine theta d theta over, since u is sine theta, we have 1 minus sine squared theta. 1 minus sine squared theta is cosine squared theta, square root is cosine theta, so we have cosine theta over cosine theta, and so we have the integral of 1, which is equals to theta plus c. So but we said u is equals to sine theta, so theta is equals to arc sine of u. So we have arc sine of u plus c, but u was set to x squared, and so the integral 2x over 1 minus x to the 4 is equals to the arcsine of x squared plus c, the integration constant. And this was in place of u. Okay, so that's it. That's all for us today. I hope you have an amazing time ahead. Thank you.